Hey, everybody. Welcome. Thanks for taking the time again to come see this workshop. I'm joined today with one of my partners in crime, Alex Debris. He's one of the pillars of the DynamoDB community, and we're here to talk to you a little bit about, serverless with DynamoDB and Lambda, get you started with some basic examples of how to get up and running. And we'll get to that in a minute. My content today in this session is really more about talking about the fundamentals of DynamoDB. As usual, I want to talk a little bit about why are we using NoSQL. It's important to understand, what workloads fit with the NoSQL databases. We're going to talk a little bit about DynamoDB. But really, the meat of this is about DynamoDB and the serverless ecosystem. Some of the fundamentals of data modeling, they're very important to understand when we're talking about DynamoDB. We're going to cover that. But it's really about the virtual workshop. So we're going to talk mostly about, some of the fundamental constructs that we need to understand and why are we using this technology. And we're going to get right into that. And Alex is going to run you through a pretty nice agenda of content that we have today. So again, the first thing we want to talk about is why NoSQL. When does it make sense to use the technology? And it's really not for every workload. It's for a very specific category of workloads, as a matter of fact, and those are the OLTP applications, things that have regular repeated access patterns. They're well understood queries. When you're dealing with databases like a relational database, these are technologies that are, they built on normalized relational models. They're agnostic to every access pattern, and they give a nice ad hoc query engine in front of the database to be able to support, those types of ad hoc queries, but they don't do it very efficiently, right? NoSQL databases are about efficiency. So when I have a workload that's running a regular repeated, set of patterns of access against the data, it makes more sense to tune the data model, so to speak, for that. And that's something we learned at Amazon. So if you think about it, the OLTP application works really well. Those OLAP applications where maybe an analyst is coming in and writing, queries against the data, maybe not so well. But it's a good thing for us, for NoSQL people, because 90% of the applications that we write today are OLTP applications, right? That's what we're writing code for. You don't write code to ask random questions. You write code to ask specific questions, right? So if you're writing code to automate a process, it's probably a pretty good fit for NoSQL databases. Now, DynamoDB is really about performance at scale and kind of elastic provisioning of capacity. It's a completely serverless architecture. There's no hardware provisioning. You don't have to say how. All you need to do is tell us. You don't even need to tell us how much you want to get. But we have pricing models for on demand that'll deliver completely elastic performance. We have better pricing, the more discounted pricing if you understand how much you need to provision. But again, it's completely serverless architecture. Fine-grained access control is built into the system. I can authorize processes to work against the data. They have visibility to the table, to the items on the table, to the attributes within those items. Features like global tables, built-in replication, 5 nines availability out of the box. These are things that you don't necessarily want to be responsible for running. DynamoDB gives you a completely managed service to do all of that, and a highly performant service we'll talk about in a minute. When we get into NoSQL databases, we need to understand a little bit about how the data is structured, how the data is modeled. And every NoSQL database, I like to think of a NoSQL database as an indexed object collection, right? So all NoSQL databases have some sort of collection. In DynamoDB, we call it a table. In MongoDB, it's collection. DocumentDB, also a collection. Cassandra, this might be called a key space. But regardless, there's some sort of container with which we're going to insert items. Items have attributes. Not all the items have to have the same attributes. And you can kind of think of these items as the rows from your relational database tables, right? All those tables, all those different rows that you have across all those tables, we're going to push all these things into one place, right? One collection. And every one of those items is going to have a unique identifier. In DynamoDB, we call it the partition key. DocumentDB, it's underbar ID, right? In Cassandra, it's also called the partition key, but there's some unique identifier for the item on the table or in the collection, and that gives me the ability to support this key value access pattern. And this is the fundamental access pattern that everyone's familiar with when we talk about NoSQL databases. Unfortunately, and it's not so simple when it comes to real data. Not all the data works. When we access the data on the database, in the database, there's relationships between that data, and we need to express those relationships. And this is where you get into, non-relational data. What is it, right? Honestly, I don't know if it exists. I've never been able to find it. And in NoSQL databases, what we're going to do is we're going to build indexes. We're going to build compound indexes or that are going to establish these types of structures in DynamoDB, where we have maybe a partition key and a sort key to describe an item. Now, the partition key uniquely identifies a container with which the item belongs, and the sort key uniquely identifies the item. And this gives us the ability to start expressing these one-to-many relationships, or these types of relational constructs, these hierarchical trees, whatnot, things that are relative to the way the data needs to be expressed, right, within the application, right? Your application doesn't work with a big blob of data. Your application works with little pieces within that hierarchical structure or that relational structure, and we need to be able to represent those relationships. Now, what I can start doing is using range operators on those sort key attributes to create filtered subsets or collections of items that are interesting, to the application. So the example here might be the partition key could be a customer ID, sort key could be an interaction date concatenated with an interaction ID, and the access pattern might be give me all the customers' interactions in the last 30 days. Maybe I log into a customer portal and I need to get all that data. And that's going to be a nice quick query against the database. It's going to bring back all of the customer's orders, shipments, invoices, payments, everything that the customer did, tickets they opened, whatnot. And I can now populate the landing page for the customer when they come into my customer portal with a single query that expresses those relationships that are interesting to me, right? Everything the customer's done in the last 30 days across all my tables. I can do this because all those objects are stored in the same place. Now, when we get into expressing additional or supporting additional access patterns, what we're just going to start to do is decorate these items with additional attributes that are interesting to aggregate on as well. We're going to define indexes on those attributes to express these relationships, right? So it's not that NoSQL databases don't allow us to express the relationships. What they don't allow us to do is join across tables. But that's okay, because everything lives on the same index, because it all lives on the same table. And essentially, that's what joins do. Joins join indexes across tables. So it's actually quite interesting. But when you get into modeling the data, and that's not really here what we're talking about today, we're talking more about serverless architectures. But it's important to understand these fundamental constructs of NoSQL. And one of the things that we look at when we talk about indexes is projecting the correct amount of data to those indexes, right? When we have secondary access patterns, I might not necessarily need to get all of the same data that I need on the table. And because of this, DynamoDB indexes support projections. Indexes, essentially, as we talked about, they're regrouping these items, defining new partition keys, new sort keys for all those items across those partitions, essentially regrouping or rejoining those items on different dimensions. But when I do this, if I don't need all the data from those items, then I don't want to project all the attributes from those items to the GSI. And this is really access pattern dependent, right? Depends on what you're doing, what I need this data on the table for, or on the index for. Maybe I only need a list of items that match a particular condition. So I'm going to create a keys only index. Only the items that match these conditions are interesting to me. Then when I get that list, I'll go back and get the one item or the worst item, so to speak, or the one that expresses the strongest relationship, and I'll get the extended attributes. And I might do this to reduce the cost, right? Because indexes essentially are, you can think of them as derivative tables that are maintained by the system. When I write to the table, the index gets a copy of whatever data I tell it to send over there, and that increases the storage cost and increases the consumption of throughput. And so just make sure you're aware of that when you're creating your indexes. Don't always just blindly select only project all your attributes when you need them. Project a subset when you don't. And project none if I don't need any of it. But again, that's up to you. It depends on the access pattern. Now we get into scaling. This is important because scaling DynamoDB happens horizontally. As we scale serverless architectures and we start to increase the number of partitions on the DynamoDB table, we're increasing the number of processing instances on the stream that are available for processing your workload. So we want to get these workloads spread out horizontally, nice and evenly across the key space. If we don't do this, we're creating bottlenecks on the system, right? So the way this works in DynamoDB, in all NoSQL databases, so we're going to take that partition key attribute that you've given us. We're going to, in DynamoDB, hash that into a arbitrary key space. And now if I have a small system, a small table that's maybe under 10 gigabytes with just a small amount of throughput, this might live on a single storage node. But as I increase the amount of throughput or the amount of data on the table, I'm going to start chopping those partitions up and spreading them out across physical storage nodes. And now what happens is I'm creating a parallel processing architecture. Each one of these storage nodes is going to have its own stream processor. We'll talk about that in a second. But when I query the system, I'm going to basically tell it, hey, here's the partition key I'm interested in. I want partition key ID 2. And I'm going to go ahead and route that request to a very specific storage node, which allows me to scale linearly across partitions. This is how NoSQL databases scale. Every single one of them does this. In DocumentDB, this could be a shard key. MongoDB calls it shard key. And same construct applies in all NoSQL databases. I need to be able to chop that key space up somehow, and to be able to maintain fast, consistent performance, I need to be able to route the query to the right node without having to query all the nodes and wait for all those responses. So this is how NoSQL databases do that. With DynamoDB, there's a real benefit to the system. It's fully elastic. If I start to look at how legacy technology is deployed, if you look at the chart on the left, I'm going to deploy for peak utilization, right? If I have a legacy NoSQL database or some sort of a relational database, there's no choice but to get an instance that is sized to do X. And when I'm not doing X, then I'm paying for it. So all of that white space underneath that red line, that's simply a wasted dollars. On the right-hand side, what we're seeing is just-in-time provisioning. This is auto-scaling from DynamoDB. If your workload fits this type of pattern, it's really nice. This is what makes DynamoDB the backbone database for serverless architecture, right? When we talk about serverless, what we really want is just-in-time provisioning for our workload. We don't want to have pre-provisioned server instances sitting out there waiting for work and then doing nothing 90% of the time. And that is the average enterprise workload operates at about 15% infrastructure utilization, right? So with DynamoDB, you get that just-in-time type of provisioning. And with auto-scaling, this is great because most workloads operate with kind of a nice curve like this, right? Your workload starts to peak as your users come online. Whenever that workload period expires, it kind of rolls off the back end. Seldom do you see very vertical spikes in traffic. You're seeing things that kind of ramp as users become available or start to work the system. Sometimes, however, we have workloads that are more vertical than this, right? They're like instantaneous. I have all of a sudden a flood of users coming into the system, or some sort of spurious amount of traffic that's coming based on it's event-driven and it's unpredictable. In that case, we can run in what we call on-demand capacity mode. This is a little bit more expensive than your provision throughput mode, right? With auto-scaling, we're running in provision throughput. We're just adjusting the amount of provision throughput based on your CloudWatch metrics. But that takes 12 minutes or so, 12 to 15 minutes to respond to increases and fluctuations in traffic. Whereas on demand is instantaneous, right? As you start to within certain boundaries that we will deliver, and we won't get into the details of it. But suffice to say that if your tables are properly configured and your traffic bursts to maximum throughput instantaneously with an on-demand table configuration, we're going to support that increase in traffic seamlessly. Now, again, it's more expensive to run this way, so we want to try and look at your workload and see where does it fit. Does that demand curve fit into an auto-scaling environment? Let's put it there because you're going to run much cheaper. Does it not? Let's look at on-demand. I have customers who have saved significant amounts of money with on-demand because they don't have to maintain high levels of throughput at a constant rate, right, to be able to satisfy these peaks and bursts. DynamoDB gives you that. Again, we talk about elastic performance, but it's really amazing performance at any scale. As you increase the throughput to your DynamoDB table, this is a synthetic workload. We ran up to millions of writes, millions of reads per second. What we're actually seeing is that get latency on the right-hand chart decreases as the read requests per second peak into the millions of requests per second range. And the reason for this is this fully distributed request router that sits in front of the DynamoDB service. And it doesn't matter, you're never going to overwhelm it. As a matter of fact, what starts happening when you hit it really hard is that all the request routers kind of become aware of your table. They don't need to hit the configuration service and get the security IAM permissions or the storage node locations and whatnot. They can actually keep that in a short-lived cache. So if I'm hitting at millions of requests per second, once the request routers all cache that configuration data, then essentially only one request out of every couple millions or every couple dozen requests out of every million or so are actually going back to the configuration service. And you can see the impact of that on the right-hand chart, going from 4 milliseconds average from a cold table, to at millions of requests per second, getting into the 2.5, low 2 millisecond range. And then, of course, as the load tapers off, the request routers start to forget about the table, and the latency starts to increase again to the 4 millisecond range. So you can see how the system actually behaves counterintuitively, right? If I drive a relational database to 100% utilization, it's not going to become faster. It's going to get a lot slower. As a matter of fact, it could even go sideways and go offline if I hit it too hard, right? So these are things that DynamoDB will never do. Not only that, but it's, again, super elastic. If you talk about serverless performance, that's what you want. You want a system that can perform at the demand of the service at any time. And this is a great example of that. This is Snapchat, Super Bowl Sunday, running through the event. They were provisioned at about 5.7 million as a minimum on their auto scaling configuration. We recommend that a lot when customers are running like event days. You're going to get large amount of traffic. Just increase the minimum, because why do I need to worry about adjusting during the day? At the end of the day, return it to your nominal settings. But what happened here is at the end of the Super Bowl, right when this was 2019, I forget who was playing, but when the game ended, they spiked their traffic up into the 10, 11 million requests per second range, and they weren't provisioned for it. And auto scaling can't react that fast. Remember, I told you it takes 10 to 12 minutes, and this was an instantaneous spike. Well, they came to us the next day and said, well, how did this happen when they were only provisioned at 5.7 million and they were delivering 11 million? And again, another thing that's counterintuitive about DynamoDB is you're going to get 5 minutes of burst capacity, right? That's what we call the unused capacity for the last 5 minutes. That's called burst capacity. If you exceed the provision throughput of your table and you haven't been using the table at a high rate of utilization up until that point, then we're going to give you 5 minutes of unused capacity and try and satisfy the spikes, right? The bursts and even the load across over time. Now, there's no other database in the world where you're going to be able, no legacy technology anyways, where you could do anything like this, right? I mean, you weren't busy 5 minutes ago, please give me that capacity now. I mean, there's no way any legacy NoSQL database at this point is, going offline. They're going to be denying requests, response rate's going to be through the roof, going to be resource constrained. Those things don't happen to DynamoDB, again, because it's a massively distributed shared backplane service. And that's why it is the backbone for serverless apps. Multi-region global table replication gives you 5 nines availability at the click of the button. So again, for serverless infrastructure, it's not just about performance, it's about availability, right? I can't be serverless and have it say, wait a minute, right? Not right now. Give me, come back later. It has to happen when customers need it. And 5 nines availability delivers that type of service, guarantee that now you can turn around to your customers and offer those types of SLAs. Again, this is push button. When you deploy a single table in a single region in DynamoDB, you get 4 nines availability. When you click the button and add a new region for replication and you go across 2 regions, then we're going to give you 5 nines availability. That's an SLA guarantee. There's an availability benchmark that's in your dashboard that you can look at and see what is my table availability been, and those credits are automatic. Now, I know a lot of vendors who talk about 5 nines. There's a lot of lip service out there around 5 nines. I don't even know how many RFPs I've filled out where people look at, vendor must provide 5 nines, right? And how many people check that box, and how often do you really deliver it? DynamoDB delivers it, and we know it because it's a tier 0 service. When DynamoDB goes down, the entire AWS region is offline. Okay, because you can't stand up a region without DynamoDB, and so many AWS services have DynamoDB as an underpinning that if DynamoDB literally were to go down, then that region is going to be offline, and we've never lost that region, any region. So that's a testament to the availability characteristics of DynamoDB. All right, NoSQL data modeling. Again, we're going to talk a little bit about this because we need to understand where serverless comes in when we talk about the data models of NoSQL. We talked a little bit about how we have to build static kind of result sets, right? I'm going to design partitions on the table that contain collections of items that I can filter using sort conditions and filter expressions to get subsets of items out of there that are interesting to my application. But one of the things that's about NoSQL. We're going to demonstrate that as we go into the model. We always have to maintain the relationships between the data. And sometimes the queries that we run, they're not so simple, right? So when we're looking at relational data, it's very easy. It doesn't matter what type of application I'm running, social networking, document management, IT management, systems management, anything I'm working with. If the data is interesting to my application, it has relationships. Okay, so anyone who tells you about this is a non-relational database, well, that's not really true. If we can't express the relationships in the data pretty close to the same way that we do in the relational database, then whatever we're doing is not going to be as efficient as it needs to be to save money, right? And this is really what we found at Amazon, is that we built these giant documents, and I hear this all the time, oh, I can't use DynamoDB because it only supports 400 kilobyte document. It's like, well, excuse me, but if you're using documents that are large like that, then it's probably an anti-pattern, let's talk, because what we really want are small documents linked by indexes to create collections that are interesting based on the access pattern. Again, how do we do that? In the case of SQL, we've always done, again, these normalized relational model. I can run any query, I can get any product. If I want to get a list of all my products from this particular view of a simplified product catalog, you can see the types of queries I'd have to execute. All those relationships are expressed in the entity diagram that really maps one-to-one to my table diagram. Maybe the only thing I don't see in an entity relationship diagram might be that actor video table, right? That's the mapping table that enables the many-to-many relationship between videos and actors, right? All the rest of this stuff is pretty straightforward. One-to-one between products and books, albums and videos, one-to-many between albums and tracks. Again, that many-to-many between videos and actors, but I'd have to write multiple queries, and execute multiple calls to get all my products. Simplified approach. We're not going to get much beyond this type of a simple abstraction. But if I took all of those rows and created these product blobs, which is probably pretty accurate or pretty relevant to this particular access pattern, get me a product by ID, get me all my products, maybe get me all my products by category, right? I could simply just create these product blobs, and now I execute very simple queries, right? Select star from where X equals. It's always going to be a lot faster than inner join on multi-dimensions, right? I'm not going to get into all those time complexities. I have plenty of content out there about that if you want to get into, why, what's the time complexity of a query versus, join. But what we really need to understand when we get to serverless is about complex queries, right? It's not helpful for me to store an item and then not be able to get those counts, sums, averages, the key performance indicators, right? All the various things that our applications need, right? And one of the things that we found at Amazon was that we were creating these summary tables that had these top-level metrics, and we were computing these top-level metrics intermittently on scheduled intervals, because trying to compute them on the fly, on demand, was getting way too expensive for our relational databases. So that primary value of the relational database of being agnostic to every access pattern really meant that it's optimized for none. And as such, we were actually denormalizing that data, creating summary tables, roll-up tables. Customers would come in, they'd look for some summary data, they would make a select off the table instead of counting the items on the table and creating complex queries. So the way that we do this in DynamoDB is actually pretty neat. We have this thing called DynamoDB streams, right? Data events on the table, any type of update to the table, writes, deletes, updates, inserts, you name it. That data event is going to show up on the stream. It's going to be processed in order by item, which allows me to do a lot of cool things. One of the biggest, most common things we do are these real-time aggregations, right? We're going to send data up to, as it comes off the stream, I might read the products that are being ordered, the category of product or the items, and I can say, okay, all the products that are being ordered, let's summarize orders by item. Let's summarize, orders by category. Let's summarize whatever, right? And we're going to maintain these summary aggregation items on the table, so when users come in and need to get the most current data, they're going to get the data that was most recently posted off of the stream or updated from the stream, which is great because it's 1 to 2 second execution, right? As long as the workflow that's happening isn't backing up. We'll talk about that in a second. But if your processing of the data events is fairly lightweight, which is usually what we're dealing with when we're dealing with summary aggregations, we can typically get data that's not more stale than 1 to 2 seconds off of the stream, which is really cool. Other things we're going to do is we're going to push data out to maybe to higher level indexers like Elasticsearch for indexing options that we don't have access to in DynamoDB, full text indexing, index intersections, can kind of maintain those types of indexing stores. And then another use case, which is really powerful, is and my graphics are kind of a little messed up here, I apologize, but this Lambda to Firehose into S3 for all those audit trail workflows. I'm seeing this more and more. It's a beautiful workflow. We can take the data events off the stream. We can pipe them right into Kinesis Firehose, roll them up into a Parquet file, shove them into an S3 bucket. And now that data is accessible. Most audit trail workflows don't need low latency online data, right? DynamoDB, data storage costs are high, throughput costs are high compared to cold storage. In S3, it's 3 cents a gigabyte, right? The Athena queries only pay for those when I run them, and they're fairly efficient. So, we're talking about pennies to maintain the audit trail workflow, which is amazing, right? So, a great workflow option for you there if you need audit trail, right? So, push that data out to S3. Notify external systems of change. This is code. It can do pretty much anything you want. So, it's up to you what you want the data to do. Now, the streams and Lambda interaction, this is, again, that data pipeline that comes off the table. This is where the whole serverless aspect of DynamoDB comes in. And it changes DynamoDB from being a database into a data processing engine, right? As we push data onto the table, the stream processors are going to scale behind the table. When the table's cold, you're going to have many partitions pointing to one stream shard. As the table heats up, we're going to start to split those stream shards, and you're going to eventually see one-to-one between your table partitions and your stream shard partitions. Stream shards have twice the throughput of an individual table. So you'll never, theoretically, it's not a data processing, the volume of data that I'm trying to process through the partition will never overrun the shard processor, right? It's the amount of work that the Lambda function is doing. But again, this type of scale up of the shard processors behind the scenes, that's all happening behind the scenes. And as I scale the shards up, I'm actually going to be executing a larger number of Lambda functions, right? As the number of shard processors essentially increase. Now, I don't necessarily need to worry about, which shards are processing and how many shards are processing, but what I do need to worry about is how much processing those Lambda functions are doing, because the only knob that I get to control iterator age, right, which is really how stale the data I'm processing is parallelization of those Lambda functions on a per shard basis. I can run up to 5 concurrent functions, but no more than that. So if the data start processing load of the Lambda function starts to back up and the table pressure is consistent, eventually the iterator age will exceed 24 hours and data is going to fall off of the back. But that's not the worst problem. The worst problem is that if the iterator age increases, then essentially the latency of the processing that's happening in those Lambda functions is also increasing. So when we say 1 to 2 second latency, that's assuming that 5 parallel Lambda functions is enough to keep up with the data load that's happening on a per shard basis, right? As it starts to fall behind, so do the metrics. So this is something to consider when we're running, those top level performance and calculations. We want those things to be relatively lightweight aggregations. We don't want to do a lot of data validation and processing. Another reason to have the audit trail processing workflow, because at the end of the day, I can simply make a call to via Athena to validate all of my top level aggregations and my top level summary metrics. And I don't need to do all of those validations, duplicate detection and things like this in the real-time aggregations, right? So, because one thing Lambda does give you, it gives you, streams and Lambda gives you at least once execution, guaranteed, but it may execute more than once, right? So always run some sort of process to validate the data at the end of some period of time or whatnot. But it's certainly fine for those top level aggregations and KPIs and whatnot if these things drift a little bit during the day and then get corrected on some regular interval. The reality is duplicate execution is rare. 99.99% of the time when I run the validation workflow, at the end of the day, it's going to match exactly with what the summary aggregation is. But if I have critical metrics, critical data that needs to be consistent or made consistent, then those validation workflows using streams, Lambda, Athena to be able to do that is very powerful. All right, so what we end up with a serverless application framework, right? A data processing engine. It's not a database anymore. You throw API gateway and a Lambda function in the front of this thing. Hell, I could go API gateway direct into my DynamoDB database, and off the back end of your DynamoDB database through streams and Lambda, I can interact with an incredible variety of technologies. As a matter of fact, anything that you have available within your AWS account space. So it's almost like a serverless application deployment framework, DynamoDB in and of itself. You don't need anything else, right? It is the backbone database for serverless. Again, the elastic performance capabilities give us the ability to execute some very complex, workflows very cost effectively using the full serverless stack backed by DynamoDB. All right. So summary of what I had to say, we're talking about NoSQL does not mean non-relational. If you can take one thing away from anything I ever talk about, it's that one fact that we need to express those relationships in our data. If we can't do that, we're not going to be efficient. The application's not going to scale well. The relational database is maybe not deprecated by NoSQL, but significantly displaced, right? 90% of the workloads out there are OLTP or decision support systems that operate at scale, and that's your NoSQL playground. Use your relational database for your OLAP workloads, but unless you have a really good reason that I need to support those ad hoc query patterns or whatnot, then you should really be looking towards NoSQL first at this point, right? It's a mature technology with lots of options out there for you. And with DynamoDB, if you're talking serverless, I just don't know if there's any other choice. All right, so that's what I've got for you. Thanks so much for taking some time to listen to me. Let's get to the meat of the conversation here. And Alex is going to walk us through a basic serverless application deployment. Now, we're going to be doing this as an instructor-led workshop. We have a lot of great content for you. You can take and follow along if you can, but really, the focus here is not to get everybody kind of synced and kept up. It's more to kind of walk through the content. That's what Alex is going to do. And then on your own time, if you want, you can go through it and stand it up in your own environments. But feel free to try and keep up. Other than that, I'm going to turn it over to Alex. Thanks a lot.
Sounds great. Thanks a lot, Rick. Really fun to do this workshop because it really sort of combines my experience with Dynamo. I got started building serverless applications. That's how I got into DynamoDB. And then, of course, watching Rick's talks, that's how I learned how to actually use DynamoDB well. So always appreciate his stuff, especially the stuff on the scaling and the Super Bowl and how well that works. I love that stuff. So I'm going to, let me share my screen real quick. So just in terms of what we're going to be talking about here, we're not going to be talking hard about data modeling or even DynamoDB performance. Like Rick's got a lot of really good content around some of that stuff. What we're really focusing here in this workshop is getting some hands-on experience, building a serverless application using AWS Lambda, using DynamoDB. And there are two main patterns I want to show in this workshop. So number one is going to be the most common one. It's going to be just using DynamoDB as your primary database in a serverless application. So just like you'd use any other database, writing records to your DynamoDB table, reading records back out from your DynamoDB table, and responding to HTTP requests from users or other services or just things like that. But really connecting to your DynamoDB table in your Lambda function. That's gonna be the first pattern. Second pattern we're gonna look at is gonna be a more reactive pattern, like what Rick was saying about DynamoDB streams. So setting up DynamoDB streams where every write operation you have against your table, whether it's an insert, an update, a delete, they're gonna drop a record into that DynamoDB stream, and then you can process it downstream. You can process it directly with AWS Lambda. So your Lambda's going to get a batch of records that you can act on, and you can, maintain aggregates in your database. If you want to do that, you can fan it out to other systems. You can send it to S3 and do stuff with Athena, like Rick was saying. So those are the two big patterns we're going to show here. We're going to walk through it with an example. And I think as we go, we'll also learn some stuff about serverless tooling, about DynamoDB, about integrating Lambda in DynamoDB. So 4 modules here. The first 2 are going to be more just background, sort of getting set up with different things and learning how those work. And then the last 2 will actually be building out an application. So let's get started with the first one. And what we're going to do is just build our first Lambda function, not using anything with DynamoDB yet. So we have this all available in a GitHub repo, and you can check out the different steps just by checking out the different branches. I'm just going to check out the first branch here and look at our first Lambda function. So I have a directory called source, which is going to hold all the source code for our application. And my first file is called main.js, which is going to be my first Lambda function that I deploy. Very simple here, just 9 or 10 lines of code. I want to walk through a few things that are happening here. So first of all, on that first line, you can see we're exporting this handler function, and that handler is going to be the entry point for our Lambda function. So with AWS Lambda, you're going to upload a zip file of some code in it, and you're going to say, here's the entry point to my function. And then you'll trigger it up to some sort of event that'll trigger that function and handle that event that happens. And that event can be, an HTTP request if you use an API gateway. It can be a queue message if you're using SQS. It can be a DynamoDB stream record if you're using DynamoDB streams, S3 bucket notifications, lots of different integrations here. So this handler is what will get invoked. Then that handler has two arguments that go into it. It has an event and a context argument. So event is going to be the actual event that triggered your request. So if it's an HTTP request, it'll show, the path that was requested, the method that was used, maybe a payload body, headers, things like that. If it's a queue message, it'll be the contents of that queue message. The second argument, what you'll get will be a context argument, which will just contain context about your Lambda function and the environment, how much memory you have, the function name, things like that. So once we get in here, then we're just going to return this response. So this is a very simple Lambda function. We're just returning this object. A couple things to note there. I noticed that I have a status code property. I'm returning a status code of 200. We're going to hook this up to API Gateway, which will give us an HTTP endpoint for this. So returning that status code just says, hey, this is the status code that will get returned back to that client. Additionally, we have this body here, and I'm just going to return some JSON back, and that'll be what's returned in the response body of that request. You can see this message of hello world, just a very simple stuff. I'm also going to return the event object just so we can get a sense of what that event looks like in the browser and explore it and see how you can customize your logic based on what's coming back in that event. So that's the function code for our first Lambda function. But in addition to that, we need to sort of set up the infrastructure to provision that Lambda function, to provision our API gateway, and all that stuff. So I'm going to check out the next part here. And I'm going to create a template. And we're going to be using AWS SAM, which is the Serverless Application Model. And what SAM is just an extension of AWS CloudFormation to make it easy to use infrastructure as code and build these serverless applications using infrastructure as code, but also provide some serverless friendly constructs and primitives on top of that, like Lambda functions, like hooking up API gateway endpoints, things like that. So that's what we'll be using here. And this template.yaml, that's going to describe our infrastructure. And then our code is going to be our actual code that's going to be in our Lambda functions. So if we take a look at our SAM template here, we have some metadata up top. The most important part to have here is this transform, which is just going to say, hey, I want to enable the serverless, the SAM transforms as part of that. Give us some of those serverless primitives here. And then I have a resources section. So whenever you're using a CloudFormation template, you're going to be probably provisioning some resources, and that's what this template is going to be managing. Right now, I have one resource and its main function. What it is it's an AWS serverless function. So this is going to be provisioning a Lambda function. It's using one of the SAM primitives there. And then it has some properties in addition to the type. So it's saying, where's sort of the root directory for my code. It also has the handler here. So it's giving a path to that file, which is in source and then main.js. And it's saying, which function do I want to be my entry point to this handler? It says the runtime. And then I need to configure events to actually trigger my function, right? Because the code itself isn't that useful. We actually want that code to be invoked when specific events happen. On this first one, we want API gateway, we want an HTTP event to happen here. So what we have in this events property is an event of type API, indicating that we want an API gateway event. And then that has properties as well, including the path. So this is the HTTP, the URL path. We're just going to have it on the root path there with an HTTP method of get. Last thing I want to point out is in SAM, in CloudFormation, you can have outputs as well, which can be values that are generated after your resources there. Maybe you need to see something. For us, we want to see the full endpoint URL of our serverless application, of our API gateway that's deployed. So I'm just doing that there. It's subbing in some values from our deployed resources and gonna let us do that. So once we've done that, then I use SAM, and I'm going to be using two commands quite a bit through this. I'm going to use number one, SAM build. And what SAM build is going to do is just sort of gather up my function according to what it's defined in there, put it into a directory that'll be easy to sort of upload to S3 once it's ready. So you can see that here. If you look, there's going to be a .aws SAM directory here with a build directory within there, and you can see my function and the compiled template as well. So that's what that build command is going to be doing. And then I need to be running the SAM deploy command. And the first time you do the SAM deploy command, you need to do -- guided, and it's just going to walk you through some configuration for this. You need to set up, a stack name. So I'm going to do Lambda DynamoDB Workshop, the region, allow some role creation, just some things like this. One thing it asks you at the end is, hey, do you want to save these arguments to a configuration file? And I recommend doing yes there, putting it in this samconfig.toml. And then it'll save all these things to the samconfig.toml. You can see is right in here. Whoops. And you can see in this TOML file, it has some of those configuration options that I set up, including my stack name, my region, bucket, different things like that. So I don't have to go through that guided process every time. From now on, I can just do SAM deploy, and it'll look at that config file and make that deploy. So it's going through this initial deploy right now, and you can see what's going on here down in the lower parts. A couple things to note here is like, this is a pretty simple template, right? We only have maybe 10 or 11 lines of YAML for our resources that we're actually provisioning stuff. But it's actually doing a lot of stuff for us behind the scenes. You know, it's creating our Lambda function, but it's also creating an IAM role that'll get associated with our function that handles identity and IAM access to different resources. We'll see how to use that later on. It's also provisioning that API gateway instance for us with that endpoint and the routes and paths and all the permissioning for us. So even though this looks pretty simple, you know, SAM is really helping us out a lot there. So you can see here at the bottom, the stack was successfully updated. It also has the outputs. So remember, we had some outputs that we set up, including we wanted to see our API gateway endpoint. You can see that actual value here. So I'm just going to copy that right there. I'll pop over to my web browser and paste that in. You can see our first web request came back, and it's in JSON format. You can see this hello world part right here. You can also see the event that came in, right? So this is the actual event that was given to our Lambda function when that HTTP request was made. And you can see things like the resource, the path, right? What was the URL path that it hit? What was the HTTP method? This was a get request, but it could have been a post request or a put or a delete, whatever it is. You can see headers. You can see query string parameters. So if you add query strings to your HTTP request, you can use that to customize your logic. Same thing with path parameters. So if you have variable elements of your URL path, right? If you're building a REST API and you have /users/user ID, you can have that path parameter of user ID to customize your logic there. It'll get extracted for you. Let's just customize this a bit just to see how this works. So maybe I want to add a query parameter of, hey, main equals Lambda there. I'll make this request. I get my event back. Let's close those headers. And you can see now this query string parameters property is populated with an object that has name equals Lambda, right? And that matches the query string that I sent with my request. So API Gateway is doing all that for you to sort of extract those query strings, set it up so that you can use it easily in your application. You can do the same thing with path parameters, as we'll see in just a sec. So that's the beginning. That's just deploying sort of our first serverless application. We've got a Lambda function. We've got API Gateway. We know a little bit of how SAM works. Let's pull some DynamoDB into this. So let's check out the next step in our application. And the first thing I want to look at is our CloudFormation template. So let's provision our DynamoDB table. So we said how SAM helps you with some of these primitives that you can provision in CloudFormation, make it a little easier for you. But you don't have to use only SAM primitives. You can use sort of any CloudFormation resource that you want, including DynamoDB tables. This is one of the reasons people love using DynamoDB with serverless, because you can provision it with CloudFormation using this tooling. Works really well with infrastructure as code. So let's scroll down here. We have this new resource in our SAM template called DynamoDB table, right? And it's of type AWS DynamoDB table, which indicates the type of resource you're provisioning. And then you set up the properties on it just like you did with your serverless function before. These kind of properties here are just setting up the primary key. We're going to use a simple primary key with just an ID string. Again, not getting hardcore into data modeling here. This is just going to be a very simple application. The only other thing you need to specify as well is your provision throughput. So DynamoDB has two different billing modes. You can do provision throughput, where in advance you say, hey, I want this many read units, this many write units, and that's going to be available for you to handle reads and writes as they come in. You can also do on-demand mode, where you don't have to provision any of that up front. You can just pay per request as they come in. So I'm using provision throughput here because it fits within the AWS free tier. It's a good choice for sort of an example workshop like this. But you can choose what works for your application. Last thing I want to point out here is, you're going to refer to your DynamoDB table using its table name. And you can specify a table name in CloudFormation as you want, but you might not want to for a variety of reasons. You might want to deploy this stack a couple times in your account, maybe for a production and a staging environment, or maybe multiple developer environments, things like that. You don't want them to stomp on each other. So what you can do instead is have CloudFormation assign that name for you, and then you don't need to worry about it. So that's what we're doing here. I still need some way to get to that name once it's been assigned. So again, we're going to be using outputs like we were before. So now I have a new output here of table name. Description is going to be name of the DynamoDB table. And the value for that, I'm using this ref function, which is a intrinsic function from CloudFormation to refer to a created object. Here I'm referring to DynamoDB table, which is the name of that resource I created. And it's going to return that table name for me. So that's how you actually provision your DynamoDB table using CloudFormation and SAM. Let's move on to the next step and just see how to actually interact with that table in our application. We're not going to get into the actual application parts yet, but I want to just see what it looks like to interact with DynamoDB. So the first thing I want to do is go to our source code, and I usually have a file called client.js or maybe a utilities file where I can create a client. And it looks something like this. And I want to call out a couple of things here. Number one, I'm going to be exporting this function get client. This is how users of this module are actually going to use this module. And it's going to return a DynamoDB client for them. So DynamoDB is going to be like any other AWS service you use, where you import the AWS SDK and then create a client for that service using the SDK. It'll pick up credentials in your environment from environment variables or config files, whatever that credential chain is. Here in Lambda, you're going to have credentials injected into your environment with environment variables, and it'll just pick that up really nicely, which is another reason people love using DynamoDB in serverless applications. So that's what's going to be happening here. One thing we do that's specific to serverless applications is we want to reuse this client across Lambda invocations, right? So if you have a Lambda container that gets used once and then rests for a while and then it gets another request and is used again, it's nice if you can reuse that client. And the reason for that is it's already done sort of the TLS handshake. It's done some of that stuff, so it can go direct to the server. It's a quicker connection rather than having to do that handshake every time. So this is what we're doing here. You can see outside of my handler, I'm just setting this variable client and I'm initializing it to null. And then in that get client thing, what I'm doing is checking to see if client exists. If it does, I'll just return that client directly. Otherwise, I'm going to set that client variable equal to a new instance of a DynamoDB client. So now that client is equal to this DynamoDB client that I'm initialized. That first time we call this, that's what's going to happen. And then I'll return that to the client or to the caller of this function. The nice thing is, the second, third, fourth time someone calls this get client method, it's going to have that cached version of the client, which already has that TLS connection working for you. Finally, another good reason to sort of separate it out like this is you can set up any configuration options you want in one place rather than in a lot of different files wherever you're creating your client. So in this example, I'm setting up HTTP options like my connection timeout, like my regular just request timeout, different things like that. You can set up all in one place rather than having it scattered all over across your application. So I often have something like this, especially when I'm working with Dynamo in serverless applications, have a client.js or a utilities file. Now let's go back to our Lambda function. I've edited it just to actually use this DynamoDB client. So if you look at the top here, I'm importing that get client function from that client.js file. And then what I'm doing is I'm just using that get client to return a client and then just call the describe table operation against the DynamoDB table. It's just going to give me some information about our table, metadata, nothing sort of huge here. One thing to call out is that it requires a table name property. So what I'm doing is I'm getting that from environment variables, and we'll see in just a sec how you inject environment variables into your Lambda application, using CloudFormation. What does that process look like? And then, my code can pick that up and use it to call describe table. Another thing to note is if you're using Node.js, if you're using JavaScript in your Lambda functions, and you're using the AWS SDK, it's going to be callback driven or promise driven. So you can add a .promise to the end of any SDK method that you're going to call, and then you can await that promise. So you can use async await, which works really nicely. Just make sure you add that .promise to make that work. Finally, I'm just going to return the response of that table in a response. So again, once we deploy this, we'll be able to go back to our web page, see what it looks like, and see how it's changed from things there. I'm just going to get the SAM build and deploy going, and then I'm going to look at a few changes in our SAM template as well. So I'm doing that SAM build and deploy. While that's happening, let's go take a look at a few other changes we have here to make this work. So we have our main function set up. Two big changes I needed to do here. Number one, I talked about how we need to inject that table name as an environment variable. So you can see within my function, within the properties, I have an environment property where I can inject variables into that. So environment.variables, and then I have table name. Again, I'm going to be using that ref intrinsic function from CloudFormation to get the table name from my DynamoDB table. This means CloudFormation can name my table. I don't have to worry about it, and I'll just inject it into my function using that environment variable, which can pick it up and use it to call the DynamoDB SDK. The second thing we need to do here is we need to give some IAM permissions to our Lambda function, right? Because now our Lambda function, it's not just returning the event back to us, it's actually calling out to our DynamoDB table. So we need to give it permissions to do that. So that's what we do here in this policies section in our Lambda function that we've created there. We're going to add a single IAM statement onto that, give it a name, give it an effect of allow, and then we're going to add this action. So here's an action you have here. The action format is always going to be the service name and then the operation you want to do. So in this case, it's DynamoDB : and then describe table, right? Because describe table was the method we were calling in that SDK to get that response back on our DynamoDB table. So that's the format you're going to use there. It's usually pretty easy to figure out which IAM permission you need because it's going to match up with that method call in most instances. And then finally, which resource does it apply to, right? Because maybe we don't want to give permission for this function to access all of our tables. We only want it to access one. So we're going to give in the ARN of this particular resource. So for this resource, we're going to use the get@at intrinsic function. This is similar to the ref intrinsic function where you can get a particular attribute on that table. So we have DynamoDB table.arn because we want to use an ARN for that resource there. So those are the two things we had to add here: an environment variable with our table name, and then number two, IAM permissions to actually call that describe table operation. You can see down below that our stack has completed successfully. So let's go back to our thing, and we'll just refresh this here. Let's see what this looks like.
Alex, we had a question here. Interesting question. I thought, how to debug through AWS SAM, when you're running a local Docker container. I don't know if you have any feedback on that, but could be interesting.
Yep, sure. So AWS SAM does have like a built-in, I believe the command is start API, AWS SAM start API or start local. You have to look at the docs for that, but you can actually start and run it locally. And especially if you're using API Gateway and Lambda, you can do that locally and actually have local endpoints that you're hitting for that. You can run DynamoDB local, which is like a local emulator of DynamoDB, and configure your Lambda function to hit that if you're running locally as well. The other thing I recommend is just deploy this to your own developer account and have those resources in the cloud and get used to deploying it and debugging in the cloud because it's going to be a more natural environment. One thing is if you're running locally, you might not have the right IAM permissions configured. You might have more expansive IAM permissions locally than your function actually has. So it might not be a great test. So I always recommend messing around in the cloud. Although, with some stacks, if you're just using API Gateway, Lambda, DynamoDB, you can emulate that locally pretty well.
Awesome. Great. And then I guess there was a comment on if you could zoom in a little bit, maybe use some larger fonts on these screens.
Sure.
Yeah.
I'll do that in my code editor as well. Yep, absolutely. Okay, so here we are. We're back in our Lambda response here. We still have our hello world message there, but we also, instead of our event now, we have this table attribute coming in here, and it just returns the response from that DynamoDB describe table response. Not a lot of interesting stuff to see here, but the interesting part is, we were able to get that table name. We were able to set up the IAM permissions so that our Lambda function could actually call that describe table request and return it to us. So far we've covered the basics, right? We've deployed our first serverless application using API Gateway and Lambda. We've provisioned the DynamoDB table. We've seen how to interact with DynamoDB and the DynamoDB API using that DynamoDB client. So now let's get into our actual application that we want to build here. And again, I want to show those two patterns, right? How are you using Dynamo as a primary database within Lambda? So how are you connecting to Dynamo within Lambda, writing data, reading data back out and showing it to your users? And then also, how are you using DynamoDB and Lambda reactively? How are you reacting to DynamoDB events in your stream using AWS Lambda to process that stream? So we'll start with that first pattern. And the application we're going to build here is a pretty simple one, just like a page tracking application, right? So we're going to set up two routes. One will be at /tags and then tag name, which can be a dynamic variable, right? So it could be AWS or technology or DynamoDB, anything like that. Whenever someone visits that page, we'll just sort of increment a counter for that particular tag, just so we can see how many people have visited it. And then we'll add a second endpoint that's /counts/ and then that tag name, where if you want to see how many total people have seen that particular tag, you can go there and do that. So that's what we're going to do next here. Let's go back to our code. I'll zoom in a little bit. Oops. All right, there we go. So let me close that out. Whoa. That would get a little too close. All right. All right, so let's set up the endpoint to write to our DynamoDB table first. So I usually like to start with the Lambda code first rather than the infrastructure code. So that's where I'm going to start here. I've added a new file under source of recordvisit.js. You can pop that one open here. This should look, fairly similar. At the top here, we've got an exports.handler. Again, it's taking in an event parameter and a context parameter. We're also, importing that get client function because we're going to be using DynamoDB in here. So what's going to happen here is this is how we're going to write to DynamoDB when someone comes to /tags/ and then a particular tag name. So one thing we need to do is get that tag name. And the way we'll do that is with path parameters. So on that event object that came in, it's going to have a property called path parameters and then a named parameter called tag. And we'll see in just a second how to set that up in our SAM template using path parameters in our API gateway configuration. But we'll just extract that tag name, right? So if someone came to /tag/AWS, this value is going to be AWS, or /DynamoDB, this will be DynamoDB. And then what we're going to do is just call an update item operation on our DynamoDB client. So again, we're getting our DynamoDB client. We're calling update item. It's getting that same table name from the environment like we did before. In order to do an update item operation, you need to provide the primary key of the item that's being updated. So that's what we have here. We're identifying that item by its tag name, right? So the ID is going to be its tag name. And then we'll just do an update expression, which is going to increment that count value by 1 for that tag. So it's got a little logic in here to help initialize it, right? So if this is the first time that a tag exists, it's not going to have an item. It's not going to have a counter. So what we do is just initialize that count to 0. Otherwise, if that item already exists, we'll take a look at the current count, increment it by 1, and pass it along. And you can look a little bit more about update expressions, expression attribute names and values elsewhere in the DynamoDB documentation. We'll do that promise, wait for that to happen. Once that happens, we're going to come down here and return a response to our users. A lot of the same as what we did before, but I do want to call one thing out, right? We have our status code again, but this time we're going to actually return some pretty friendly HTML rather than just JSON. So in our body here, you can see we're just returning HTML with divs and H1s and H2, all that sort of stuff. So you can return any sort of content type that you want to your users, JSON or HTML or XML or whatever you want to do. You can also pass in custom headers. So here I'm going to indicate that content type of text HTML so that people know, or so the browser knows, how to handle this particular content that's coming back. Again, I'm just going to do the SAM build and SAM deploy to get that going while we look at our template and the changes we have to make in our SAM template as well. So in addition to creating, the code for our Lambda function, again, we have to sort of provision it using that infrastructure as code in our SAM template. That's what we have here. We still have our main function, which I've just collapsed down, but we also have now this record visit function. This is going to be a new function. It's going to be of that same type, AWS Serverless function. A lot of this configuration is going to be similar, right? We're using a code URI. We have a handler that's pointing to this file now. So it's pointing to source record visit rather than source main. So you just need to know, hey, which file am I pointing to and what's going to handle it? Again, using that Node.js runtime. Again, having an HTTP event here. The only big difference here is in that path, right? We want to sort of have this variable path property. And the way you can do that is with curly braces when you're defining that API gateway path. So in this case, the route is going to be /tag and then / and the tag name, AWS, DynamoDB, technology, whatever you want it to be. So we're saying, hey, capture this value that comes after /tag and name it the variable tag, and then I can actually use it in my Lambda function using that path parameters object that I was showing before. Same thing here, we're passing in the environment variable of the table name there. We also have some policies. This is a slightly different policy because this one is going to be update item rather than describe table, but it's the same basic structure on how to do that. So again, a lot of that's similar other than that path parameter property we pass in here. You can see our deployment just completed. So let's pop over to our browser and test this out. So I'm going to go /tag and let's do technology, right? Oops. Might not, maybe slightly too soon here. Oh, did I do it wrong? There we go. Okay, so it takes a few seconds, especially after that first deploy, to get it. So you can see I visited tag /technology. You can see, hey, your visit counts. We counted it. We've also got a link here that says check the count for the tag technology, but we haven't actually implemented that, so we gotta make sure that works. Let's just give it a few requests and hit it a few times so we update that count. Maybe we could also try something else. If we like sports, maybe we want to do the NBA, and you can see how our HTML output changes based on the tag that we have up here, right? We can go to AWS, we can go to whatever we want here. So that's how we're actually writing to our DynamoDB table, but it's hard for us to even tell that write actually occurred because we can't see that count yet. So let's go back and actually implement how do I view that count for a particular tag. So I'll come back here. All right, so again, I'm going to have a new Lambda function for this one. This is going to be at /counts and the actual tag name. So I always start with the Lambda function code first. So let's go to this view counts.js file. Again, pretty similar setup. You can see I have my Lambda function handler that I'm exporting. I have the event and context object that I'm doing there. I'm importing that get client function. So a lot of your Lambda code is going to have a lot of similarities between it. You can also see I'm extracting the tag from the path parameters. This is going to help me figure out which item I want to go and retrieve to display the counts for, right? So then I get down, I'm calling get client, and then this time I'm retrieving an item. Rather than writing an item to DynamoDB, I'm reading one back out. So I'm going to call that get item method on this. Again, I'm passing in that table name, and on that get item, I need to specify the primary key of the item I want to retrieve. So here I have key. It's an and the ID is the tag there that I extracted. Once I get that request back, it's possible that this item doesn't exist. If someone tries to check the count for a tag that no one has ever visited, there's not going to be an item in my DynamoDB table. So what I'll do is I'll just initialize that count value to 0, and then I'll say, hey, in my response, did I get an item back? If I did, update that count to the count property on that item I received and return it. Otherwise, keep it at 0. And then I'll just return some HTML again. So not a lot of changes there. I'm going to do a SAM build and deploy. Well, we go take a look at the template changes we had to make as part of this one. So we've got our two functions before. We got our main function. We've got that record visit function. Let's look at our view counts function. And a lot of this is going to be similar. Again, type of AWS serverless function. Same thing with the code URI and handler pointing to the actual new file we've created and the handler function there. You can see in the events thing, we're doing type API. Again, we're using a path parameter because we want to extract that parameter to figure out which tag people are looking at. So we have /counts/ and then curly braces tag to help extract that tag parameter. You can also see, we have that environment variable. We're pushing in that table name. The one thing that's interesting and a little bit different here is in this policies section, right? So previously we are writing our IAM statements by hand. We were saying, hey, here's the action I want to do. Here's the resource I want to do it on. But SAM has something called AWS SAM policy templates. And what these are pre-configured templates for common access patterns, common patterns that people are doing in serverless applications. So they have 15 or 20 of these that can help you. The example I'm showing here is the DynamoDB read policy. So a lot of times you're going to have a Lambda function that wants to read from a DynamoDB table. You don't want to give it write access. What you can use is this DynamoDB read policy. You pass in the table name like this, and it's going to handle the rest of that policy for you to make it all work for you. So I'd recommend looking at these AWS SAM policy templates, and it can ease some of that burden of managing IAM and figuring out how all that stuff works for you. So check those out. You can always write your statements yourself if you want to, but this is a good alternative as well. If we look down in our terminal, so our stack was updated, so we can go check out the changes there. Let's go back to this and maybe refresh this. Okay, so your visit counts. Let's actually click the link this time, check the count for the tag AWS here. See if this actually works. And there we go. So it's saying the total number of visits we have for our tag AWS. It has 2 total visits. You can see our route is /counts/AWS. So that's that unique tag property, right? We can go to technology if we want to, which we visited a few different times. It had 4 total visits. We haven't gone to DynamoDB yet. So let's see what happens if we go to DynamoDB. That one's got 0 total visits. So you can see it can handle the case where it doesn't exist. It can also handle the ones where it does exist. So that's what we've had so far, and that's our first pattern we've seen, where we're writing to, we're reading back from our DynamoDB table. This is going to be very common. This is where all the great work that Rick and the team have done around data modeling will come into effect, where you model your data well, and then you can actually use it in your Lambda function like this. The second pattern I want to show is that reactive pattern, where we enable DynamoDB streams on our table and start reacting to these changes that happen in our table. So let's take a look at that one now. I'm gonna close these out. So the first thing we need to do is enable DynamoDB streams on our table, because by default, DynamoDB streams aren't enabled. When you enable DynamoDB streams on your table, you need to think about 2 things. Number one, you need to think about the stream view type, which is basically saying, how much information do I want on that record that goes into my stream? And on the very sparse end, you can say, hey, just tell me about, you could do keys only, which basically just says, hey, you tell me which type of operation, was it an insert, an update, or a delete? And also tell me the primary key of the item involved, and that's it. And I sort of have to go retrieve the item if I want to do anything about that. On the far other end, you can do new and old images, which will say, it's going to tell you the operation that happened. It's going to tell you the primary key of the item affected, but it's also going to show you the full item as it existed before the operation and the full item as it exists after the operation is complete. So you can compare those and see what changed, and maybe that affects some of the downstream logic you have there. So that stream view type, that's the first decision you need to make. The second decision you need to make is just sort of your streaming mechanism, right? So you can use just the DynamoDB streams, sort of built-in mechanisms within DynamoDB to handle that with your streams, or you can use Amazon Kinesis for your streams, where they'll actually send those records to Amazon Kinesis for you. In terms of like pros and cons, I would say DynamoDB streams is a more managed experience, and you don't have to really think about scaling or handling any of that. It's all happening for you. It gives you a little less control over stream retention time or parallelism or different things like that. Whereas on the alternatives, Kinesis streams, you have to manage a little bit more of the shards that you have in your stream and scale up and down if you need to. But it's going to give you longer retention capabilities if you need it. It's going to let you use enhanced fan out consumers from Amazon Kinesis, some of those Kinesis features. So you can look at those 2 things. By default, it's going to use the DynamoDB streams feature, and that's what I'm going to use here. And I'm going to choose to use new and old images for our stream. So let's see how to configure that. We're going to go back to our SAM template here, and we have our DynamoDB table. If you look at the bottom, all we're going to add here is this stream specification, which says the stream view type. I'm specifying both new and old images, which means I want sort of everything dumped into my record, and I can do everything there. I'd recommend this if your items are pretty small, because it can be more useful there. If you do really have, big sprawling items, multiple kilobytes or things like that, then maybe you want to do keys only or just new image, just old image. It can depend on your use case, but this will work good for our case. So one thing that's nice about this is this is our existing DynamoDB table. We can change some attributes on it. We can add a stream, and CloudFormation will know, hey, can I keep the existing table and just sort of change the attributes? Do I need to delete the table? In this case, this is an additive change you can do. You can just add a stream. It's not going to delete all your existing data in your table, and CloudFormation will handle all that for you, which is really great. So once we've configured that, let's see the code and some of the other configuration we'll need to make this work. And while that's happening, while we're walking through that, I'm going to just get a deploy going, make this all work. So first thing I want to look at is just this event.json file I have in here, right? So we talked about in your Lambda function how you're going to get some sort of event in there indicating the event that you're operating on, whether that's an HTTP request or an SQS message or DynamoDB records. We already saw what that HTTP record or event looks like. This is an example of a couple DynamoDB stream events. So what you're going to get here in your DynamoDB stream processor is an object with a records attribute, and it's going to include an array of records within there. So you can actually control the batch size of that DynamoDB stream to your Lambda function as you're working with it. So you can get multiple records in a single request. If we look at this first record, a couple things I want to note here that you'll really probably want to look at is the event name. So event name is going to say what type of operation happened, right? If you're writing a new item, it's going to be insert. If you're updating an existing item, it's going to be modify. If you're deleting an item, it's going to be remove. So insert, modify, remove, you can tell what kind of operation happened on that request. You can also look in this DynamoDB property, and it's going to include things like keys. So it'll indicate the primary key for your item, which is going to uniquely identify your item. It's going to be crucial to how you do data modeling. So that's going to be an important part that's always going to be included there. This one you can see also includes the new image. So this is the item as it looks after the right operation was applied. Because this was an insert operation, this was creating a new item. There's not an old image to show here, right? Because it didn't exist before this operation. So it changes just a new image here. If we scroll down, here's a second record we have here that has the event name is modify. So that indicates we're updating an item that already existed. So in that case, we're going to have both an old image and a new image. So you can see in this DynamoDB section, we have an old image that says, hey, this is what it used to look like before the update. And then we have a new image saying, hey, this is what it looks like after the update, right? So you can operate on both of those things as needed to sort of update your logic there. There's an example of this up in the documentation if you need to go check that out and just see that structure of that DynamoDB stream event. Let's write a Lambda function that'll actually process this stuff. And what we want to do here is, we've been maintaining counts of all these different tags, but maybe we want to maintain an overall count, right? Across our entire site, we want to say, this is how many total visits we are, and as well as displaying the count for a particular tag. So that's what we're going to do here. Let's look at our stream processor function. Looks pretty similar. I have my exports.handler at the top that takes in those two arguments, event and context. Remember that the event is going to be different here. It's going to be a DynamoDB event rather than an API gateway event, but the signature still looks similar. Again, I'm pulling in this function to help me get a client, a DynamoDB client. I also have this value updated here, and what I'm doing is just saying what the key is going to be for that overall counter, right? And I'm just setting that as sort of a static property. That's what the primary key is going to be for that item that's maintaining my overall count. So then when I get to my actual function logic, what I need to do first is actually filter out some records that maybe don't apply in this situation. And there are two types of records that won't apply. Number one, if a record is being deleted from my DynamoDB table, I don't want to increment a count because that's not showing a new page visit, right? I only want to increment the count if it's an insert operation or a modify operation. So I have this filter here to say, hey, if the event name is insert or modify, I want to operate on it. Otherwise, kick it out of there. The second condition I have in my filter is I'm filtering out records that have whose ID is equal to this counter key that I'm specifying there. What I'm doing here is preventing this recursive infinite loop, right? Where if I had a tag visit come in, I want to increment my counter key. When I change my counter key, that's going to drop a record into my DynamoDB stream saying, hey, this record was modified. And if I took that and incremented the counter again, well, it would do it again and again and again over and over and wouldn't stop. So I don't want to increment my counter when I'm just modifying that counter key. I only want to increment the ones that are actually changing one of the tags on my site. So that's what we're working on here. Once we have that, we have our filtered records. Maybe we got in 50 records and only 20 of them are relevant here, but we have some array of filtered records. And then I'm just calling an update item on that counter key, very similar to what I was doing with the tag name before. That update expression is going to be similar here. The only big difference is the size of my increment might be different, where on that tag for a page visit, I was always incrementing by 1. In this case, I'm incrementing by the length of the filtered records, right? It might be only one record, but it might be 30 or 40 records or something like that. So it could be any length there, and making that request. And that's just all my stream processor is doing, is sort of making that little change there and writing it to DynamoDB. Let's take a look in our SAM template and see what it looks like to configure this function, because it's mostly the same, but a little different here. So now we've got our 3 functions that we had before, and we've got our new stream processor function as well. Again, type AWS Serverless function. It's got the code URI handler runtime that we've had before. The big difference here is around events, right? Because I'm not doing an HTTP API event anymore. I'm doing a DynamoDB stream event. So you can see I'm specifying of type DynamoDB rather than type API that I was doing before. So this events section, that's where you can set up the different type of events that are triggering your Lambda function. This time I want DynamoDB. And then it has different properties according to that event type. So in this case, I need to pass in the stream. To do that, I'm using that get at intrinsic function from CloudFormation to get the ARN of my stream in my DynamoDB table. You can see that syntax there. Starting position, this just says, hey, when you first deploy this for the first time and you start processing that stream, do you want to start at the beginning or the end? I'm going to start at the beginning. And then you can configure the batch size, which could be 1. It can go all the way up to 10,000 as well. I'll just set it to 100 here. And then we got environment variables, policies, things like that we've already done before, because I'm going to be updating that counter record in my DynamoDB table. Very last thing I want to show is in our view counts function, we'll just update that to also indicate the total counts across our website. So we've been showing the tag counts. We're also going to show sort of the overall count as well. So I've just added a second get item request that's going to get that counter object and set that total count property and then return it in our HTML. So let's navigate back to this. And to do this, let's go back to a tag. Let's do technology. All right, so we just visited this technology tag. Maybe let's do it twice. And again, our visit counts. Remember what's happening now. We're updating that technology tag, but now also asynchronously, our stream processor function is reacting to that DynamoDB update to that technology tag and updating our counter tag. I want to look at something here. So let's go check at the counts here. And it has the total counts. One thing I want to point out, and I did this way specifically, is this is kind of wonky because it's like, hey, the technology tag has 6 total visits, but then you have 2 visits across all pages. And why is that sort of out of sync happening? When you enable DynamoDB streams, it's only going to be enabled from when you actually set it up and configure it. So if your table has been around for a day or a month or a year or 10 years or whatever, and you enable DynamoDB streams, it's not going to have write operations that occurred before you enabled that DynamoDB stream. So, we visited some different tags before, racked up some counts and things like that, but our overall counter, our stream processor doesn't know about those. So in that case, our numbers are kind of wonky here. So if you're doing something aggregation like that, you're starting down the road, you're going to need to perform some sort of ETL process to make sure you're processing everything that's already happened before you start doing this aggregation. But other than that, this will work well. You can go to other pages here, right? And it'll show the visits for this tag and also the visits across all pages, and you can see it increment as you go. So again, that's that second pattern we want to do, where you're reacting to changes in DynamoDB. You're using DynamoDB streams and processing it with Lambda, where all you really need to think about is that logic of processing that record. And do I want to update records in my table? Do I want to, fan it out to other systems? Do I want to send it to S3 for aggregations, analytics, things like that? So that's how that's working. That concludes this section. I'm just going to do, to get rid of this, I'm going to do a SAM delete, actually remove my application, and that'll remove, it'll ask me a few questions here. Do I want to delete my stack? Do I want to delete my folder? Yep. And that'll clean up everything I did there. So all the stuff I provisioned with infrastructure as code, this will send this up to CloudFormation and say, hey, delete all that stuff. Delete those 4 Lambda functions, delete that API gateway, delete that DynamoDB table and its stream and all that stuff. And I won't have to be paying for anything. So that's it. That's how that concludes the workshop. We saw how to use DynamoDB and serverless. We started off with just deploying a basic serverless application. Then we saw how do you interact with Dynamo, how do you provision that DynamoDB table and use that client to make requests to DynamoDB. And then we saw those 2 patterns that you see a lot in serverless applications, where you're using Lambda directly to reach out to DynamoDB, to write items to Dynamo, to read them back out, using Dynamo as your primary database, and then also using DynamoDB streams to enable that reactive application, react to events that happen in your table.
Cool. Hey, Alex, we got another good question here. It's kind of relevant to the topic here. So when Lambda is listening to DynamoDB stream events, is best practice do everything in one Lambda or evoke worker Lambdas? I talked a little bit about this. Maybe you want to add some of your insight on that.
Yeah. So you're saying you have like a few things happening within
Yeah, so apparently that's the question. Yeah, how much? I mean, I guess is there. Do you have any guidance for when a cut line might be in that Lambda streams interaction?
Yeah, it depends a little bit on like how likely failure is as well. The big thing that's unique about streams is your consumer is going to process them in order, and if you fail on a record, it's basically not going to be able to progress from beyond that part. So if your Lambda function fails, it's going to go back to the stream, get that batch again, reprocess it again, and if it keeps failing, it's just not going to get past that, and you're gonna lag behind. So I generally say, if you're doing exactly one thing in your stream, then it's probably fine to just do it directly in there. But if you're doing a couple different things, and especially if one can fail while the other one succeeded, you might want to farm it out in other different ways, whether that's sending it
that's really what it comes down to, right? If it's a fast operation, I talked a little bit about this. You want those stream processors. You don't want the iterator age to back up. You want those things to get off the stream fast. Yeah, fork that stuff out and not have to worry about it. It's a same kind of approach that I would take as well. One of the things that people are questioning, I don't really have an answer to, I don't know if you do, but is there a repository of examples that people can go to for trigger events specifically, looking for...
In terms of the actual shape of the events?
Yeah. I mean, I guess that's what people, Awesome.
Yes, there is. Let me, I believe that the Lambda team does a pretty good job of holding this up. I can't find the link right now, but I believe there's a Lambda link called like integrating with other services or AWS Lambda with other services. If I can find it quickly, I'll try and get it up on my screen. But they have examples of all these different types of services and the events that you can actually integrate with, and get some examples there.
If you can find it, let me know, and I'll ping it on the chat window here, and I will post it into the...
Here we go, I got it.
There we go. Got it. Let me put that in there. And so many chat windows open right now. I can't figure out which one is.
Right. So this is it's working with other services in the Lambda developer guide, and it shows the different services that you can connect into. And the great thing is, it shows the structure of that event, so you can see the different properties available on it. But it also is going to tell you interesting things about working with that particular event. It might tell you specifics of how failure modes work around DynamoDB streams, and how you should think about error handling, how you should think about metrics. Same with API gateway. What's the response format that you want to have there? So I'd say that's probably the best place to go, is that AWS Lambda developer guide, just to get a sense of that.
Awesome. So this has been great. I mean, I love the content here. I think for folks who were trying to follow along, might have gotten caught behind. The content again is up there for you. Again, this was the intent of this, is we found with these workshops. I think this works much better, right? You're going through the steps. It's now there's content out there. People can follow along. They can stop, pause, and watch Alex go through this stuff. And the content's up there on GitHub for you to set all this up yourself. Everything Alex did today should be all free tier. Right, shouldn't incur any cost from doing this. So you can sign up for your own AWS account. You can walk through this entire deployment, and you don't have to worry about your credit card getting charged. So which is always a good thing. I think there was actually a feature in there. You noticed that I got to set the capacity on this table to provision instead of on demand earlier, to make sure that people didn't get dinged a couple pennies for running their the requests, right? But no, this has been really good, Alex. I really appreciate you taking your time to come out here and walk through this. I think this has been really valuable for the community.
Awesome. Yeah, thanks for having me. Great to be here. Great questions, everyone. Feel free to reach out to me and Rick on Twitter, or however you want to reach out to us if you have any questions.
Awesome. Great. So I guess with that, I don't think we have anything else to go through, so we're going to let people move on with their day. And again, thank you so much for joining us for this session. We really appreciate you all.